Introduction. So this is mainly work by John Syme and the F# team. I'm one of the first users of it. I wrote most of the demos that they use for public talks, so I may as well give a public talk about it. And I'll start with some pretty pictures. So the problem that F# is trying to solve with this is that there are these two worlds on the violet side. There's the data world, and people like working in semantic web or databases, and they speak in things like SQL, REST, JSON. This funny thing that looks like weird sheep. That's some name for description logic that you can use to model data and to write queries to data sources. And so if we try to use data from programming languages, we only understand tuples, records, unions. Some people understand classes. But that's still a completely different thing than what the violet people do. So if you're writing some application that works with external data, and with mobile phones, the only thing that applications do is work with external data, then it feels like building a Tower of Babel where you don't really understand each other. So what are F# type providers? How many people here are fans of the Hitchhiker's Guide to the Galaxy? Good. So type providers are like the Babel fish. You can stick it into your compiler, and it connects to the brainwaves of the data world and starts translating the thing that people in the data world do, the thing that we understand, like types, higher order functions, and so on. So I'll start with an example, and this is actually triggered by one experience I had some time ago with Czech politicians, where they announced that there's too many people going to university and we have to do something about it. So I'll show you some code written in F# in Visual Studio. That's Microsoft's developer environment, which comes with F#. And you can also use F# in MonoDevelop. This is an open source project that's still improving, but it's slowly getting into quite usable stage. And I'll start by this code just loads a few things. So I'll be using some charting library, but the interesting thing is happening on the first line, where the code loads the World Bank type provider. And that's a component that connects to the World Bank, which is an international organization that has lots of data about countries. And it projects that data to F# as types. So this first line just connects to the World Bank, and I'll be running the sample interactively. So I'll have on the left is code I write, on the right is what it does, the output. And the interesting thing is happening when I type data dot, because the type provider is actually working during the editor or development time as well. And this provides me with property countries. F# mixes the functional and object-oriented style through things like accessing data, where you can explore things by typing dot. The object-oriented style actually works really nicely. So what just happened is that I asked for the list of countries, and this is just some type which has properties or record, and it connected to the World Bank data source and downloaded a list of countries, so I can choose whatever country I want. Now there's huge innovation in F# 3.0, these double backticks allow you to write any funny characters like spaces in your identifiers, because that's really kind of important when you need to import data which have various labels. And when I type dot again, it gives me some property of the country. And the interesting one is this indicators, which is the data set that the World Bank has about countries. And there's about 1,000 properties about the country. Now I'll need to remember what's the name of the one I'm interested in. And now this is a label from the data store, and if I evaluate this, I'll get it prints something about connecting, and then it gives me the university enrollment. So the next thing I can do is to use the charting library and get a chart of how the data changes. So you can see that indeed there's a very dangerous trend.
So in a few years, more than 100% will be
universal. That's why we have to prevent this. But we may want to compare this with other countries. So I'll look at Denmark, for example. And I'll change the charting code a little, just to give you the name of the country. And I'll need to use the combine operation here to put the two charts together. And this downloads the data. Now, there's some part is happening at compile time or at editor time when I access the properties. And then that gets compiled to some code that at runtime connects to the World Bank and downloads the data. So that's what's happening when I run the code. And I can plot the chart. So Denmark is successfully fighting the trend of running out of the chart. Just to demonstrate, the news article that I was referring to, they were comparing the OECD, the average of the OECD. So I can just copy some piece of code here, and I'll explain this. And this is kind of showing that this data integration really works well with the usual functional programming style. So that's why I think it's really good to have these features in ML style languages. So there's the thing in square brackets, that's sequence comprehension. So we take all the OECD members. That's another type that's another feature that's imported from the data store. If you look at regions, then the World Bank has various aggregates, and it gives me countries in that region. Yeah.
That comprehension, is that materially different from a map?
Sorry?
Is the comprehension there materially different from a map? That 4C in data regions.
Yeah.
Can I summarize that as a map over a sequence type?
This is the bind of sequence, or yeah. Because what's actually happening here is that, well, for every country we get this. For every country we get a list of school enrollments per different years. So this is a list of countries generating lists of data per different years. And the yield exclamation mark, that means basically into this sequence that we are generating, emit all the elements of this list. So if I run just this piece of code, then that will give me a list which contains year value pairs for different years for every country that I selected. So for every year, there's going to be multiple items. And I'm doing this because then I can group the data by year and get for every year I'll get some number of values from the different countries, and then I can for that year average all the values I have, and so I get for every year average enrollment rate in OECD. So this will give me the average school enrollment for all OECD countries together. And it's ignoring the missing data because sometimes the data source doesn't have all the data. So the last thing I wanted to do is to take this and let's add one more line for OECD. And now we get a comparison with Denmark, Czech Republic, and OECD in the middle. So OECD is looking dangerous. This is what I've shown you is that you can use this type provider mechanism during development, and it's really helpful for discovering what information you can get from the data source. If I was doing this in some other language, I would probably have to go to the World Bank website and search their poor documentation to discover what are the things I can actually use, how to call them, and so on. And all this data access aspect is now hidden in this type provider, which is one component that had to be written. And then when you're programming against the data source, the access part is actually quite easy. It's statically checked, and it helps you during the development. So just to sort of explain how you end up in the position where F# is, if you just want to access data, then the problem is data isn't a type. You can't access properties of the data from your language directly. You can kind of do this in dynamic languages if you take things like Ruby or PHP, or Smalltalk, where you can define what's the method missing handler, and then you can write foo dot whatever and write a runtime handler that handles this whatever and connects to database or online data source. But so you get very concise syntax, but it doesn't tell you what the names that are available are. You'll only find that at runtime. And I guess everybody in this room wants to have that checked at compile time. So we need to know what are the properties of the data available. And again, this is something that people have been doing in statically typed languages using code generation. So you have some code generator that looks at your database and generates all sorts of C# crazy code. And then you can compile that, and you have some statically typed schema. But that doesn't scale, because if you look at this World Bank example, we had something like thousands of properties, and it can easily get even worse. So you just can't generate all the types. Maybe because you would have to download all schema from Wikipedia, for example, which is like 8 GB, and then process that to generate the schema. So what's happening under the cover in F# is that the type provider tells the compiler, well, here is some type, here's the name of this type, and if you want to know what the members are, then run this delayed computation. So this is all accessed on demand, and when I hit dot, it would go to the type provider to access the specific information about the type that I'm using right now. So this on-demand part is very important for data sources that are huge, and it's in the World Bank example, you could possibly download it, but there's other data sources like Freebase, which is schematized Wikipedia, and that has something like 60,000 entities. So now the type provider, it's kind of a tricky component because it's used in various stages of various things. So if you have a type provider, then technically speaking, that's just some set of functions implemented in a separate DLL or some component that you can import. And I use it quite heavily during the development, and I think that's the important thing to realize, that there's this development phase is actually very important as well. And the type provider was used to generate some IntelliSense or code completion for the types that it provides. So it gives us code-friendly or code-centric view of the data. That's one phase during the development. During the compile time, it's used for two things. First of all, it's used during the type checking to check that, for example, when I get czechrepublic.indicators.university enrollment, it's a list of int float values or something. So that's during the type checking. But it's also used in code generation, because when I write something like this piece of code, if I explore the types and maybe get the type of Czech Republic as an entity, then this tells me that this is, now that's the part where it's actually, it may connect to the database or to the external source. Now, it's telling me that this is a value of type country. So the type provider can generate new types, but they don't have to be actual types that are present in the generated .NET code. F# compiles to .NET, so normally it would generate types, .NET types that correspond to every F# type. But in this case, you can also say that some types should be erased and replaced with the implementation or sort of inline. So if you have massive data source, then what you probably want is just to replace all the property accesses or member accesses with some call that calls the World Bank service and give it Czech Republic as a string. And this way you can avoid generating lots of types that are really just wrappers for some dynamic call. Okay? So there's this, from the sort of high-level perspective, it looks like fairly simple extension. It brings quite a few interesting research problems. So there's quite a few open questions that if you're interested in, you can take a look. The first problem is, how do we map the external data sources to types? If you take the World Bank example, then it's basically just three-dimensional data view. So on one dimension we have different countries, then we have different years, and we have different indicators. And you can, what I did in the example is that I picked a country, so that gives me just 2D part, 2D section or projection or view of the data. And you could already return, say, well, countries are my types, or parts of types, and these planes are the data, and I want to get them as values as some two-dimensional matrix. But what I did is that I said, well, indicators are also types, so I can do this cross-section and get just one-dimensional list of values. But you could go even further and say country.indicator.year, and then you would get just one value. So finding the right balance of what to import from the data source as type and what to leave as values, that's a pretty tricky problem to solve. And it just depends on how you want to use it. Yep.
So could you have gone the other way and started with selecting the year and then the country and then the indicator?
So the question is if I could start with year and then select different bits. Not with the current implementation of the type provider I was using, because when I was writing, I thought, well, starting with year, I don't think that would be useful. But then what I was doing as the aggregate when I wanted the OECD data, I would actually kind of want to start with the indicator and then get it by year. So yeah, I think that there's some important question, because sometimes data are separated into schema and values, but sometimes you just get a blob of data and it's up to you how to map it. The other interesting part, which I already mentioned, is that types are provided on demand. So if you look at the standard typing judgment, then it says, well, in some gamma, E is type tau. Normally, most of the researchers just ignore the gamma because that's where nothing interesting happens. And all the interesting things about types are in the tau. But if you look at the wall of this thing that's happening in F#, then the gamma also includes all these generated types, like the World Bank.data context. And the World Bank.data context, that's some class or type declaration that says, well, it has a property of type countries, but when you just access the type provided for the first time, this is some delayed computation. And when you actually type, when you try to type check code that involves World Bank.data context, then this unevaluated type reduces to the actual type. And this may require access to the network to get some more information from the data. So that's another interesting bit. And I guess one last that I want to show you is adapting to schema change, because obviously when you access some data from the network or from the web, then the data source can change. So an example that I have here is using a local XML file. And the XML file contains a root node authors, then there's a list of author. For every author, we have a list of books. And so I can say, get author elements and get the name, surname, and birth, get all the book elements and print their title. And that gives me the output. And the type provider does some sort of type inference for the XML. But when I do some change, for example, I remove birth from Ludwig Wittgenstein, then it will, in a second, when it notices that the file has changed, if I do it the right way, that's kind of annoying. Let's see what's wrong here. Well, the idea is that if we do some change, like replace author with writer, and
your XML file was called test.xml.
Yes, this is test.xml, and I was calling
calling it
XML.
something else.
No. XML done. Well, if it was not running in presentation mode, then it would maybe after a second or two show these red underlinings. that tell you, well, something is wrong, I can't type check the program anymore because author has been renamed to writer. And in this case, there's another bug because I removed birth, so suddenly birth is an option type instead of just integer. So when you're in the development mode, you can notice that there's when the schema changes, your compilation doesn't work. So that's an interesting problem. I can talk more about the related work if you have some questions. And there's an upcoming technical report that will describe some of the things in more detail. And I guess just to summarize, the idea here is really to bridge the gap between data and types. But it's still an interesting question how to do all the aspects of it properly. Thank you.